Welcome to Maths Companion. In the last video, we have discussed some problems from the section distances. There was a homework. Let us check it now. Calculate the length of the sides and diagonals of the quadrilateral below. First of all, let us give a name for this quadrilateral. Let it be ABCD. We need to find the length of the sides and length of the diagonals. Let us take one by one. First of all, let us find the length of the side AB. The length of the side AB is the distance between the points -3, -2 and 1, -2. See, the y coordinates are equal. That means these points are on a line parallel to the x-axis. Therefore, the distance between them is the absolute value of their x differences. That is, AB is absolute value of -3 minus 1. -3 minus 1 is -4. So this can be written as absolute value of -4. Absolute value means value without any sign. Therefore, absolute value of -4 is 4. That means length of the side AB is 4 units. Now let us find the length of the side BC. C is the origin. Therefore, BC is the distance from origin to the point 1, -2. We know the distance from the origin to the point xy is root of x square plus y square. Here, BC is the distance from origin to the point 1, -2. Therefore, BC is root of 1 square plus -2 square. 1 square is 1 and -2 square is 4. So this can be written as root of 1 plus 4. And 1 plus 4 is 5. Therefore, this can be written as root 5. That means the length of the side BC is root 5 units. Now let us find the length of the side CD. It is the distance from the origin to the point -3, 1. Therefore, BC equal to root of -3 square plus 1 square. -3 square is 9 and 1 square is 1. So this can be written as root of 9 plus 1. 9 plus 1 is 10. Therefore, CD is root 10. That means the length of the side CD is root 10 units. Now let us find the length of the side AD. It is the distance between the points -3, -2 and -3, 1. See, the x coordinates are same. That means these points are on a line parallel to the y-axis. Therefore, the distance between them is the absolute value of the y differences. That is, length of AD is absolute value of -2 minus 1. -2 minus 1 is -3. So this can be written as absolute value of -3 and that's equal to 3. That means the length of the side AD is 3 units. So we have found the length of all the 4 sides. Now let us find the length of the diagonals. Therefore, AC equal to root of -3 square plus -2 square. -3 square is 9 and -2 square is 4. Therefore, this can be written as root of 9 plus 4. 9 plus 4 is 13. Therefore, this can be written as root 13. That means the length of the diagonal AC is root 13 units. Now let us find the length of the diagonal BD. It is the distance between the points 1, -2 and -3, 1. We know the distance between 2 points is root of x2 minus x1 whole square plus y2 minus y1 whole square. Here x2 is 1 and x1 is -3. y2 is -2 and y1 is 1. So this can be written as root of 1 minus -3 whole square plus -2 minus 1 whole square. 1 minus -3 means 1 plus 3 or 4. -2 minus 1 is -3. So this can be written as 4 square plus -3 square. 4 square is 16 and -3 square is 9. So this can be written as root of 16 plus 9. 16 plus 9 is 25. Therefore, this can be written as root 25 and that is equal to 5. That means the length of the diagonal BD is 5 units. Now let us do the remaining problems on page 146. Prove that by joining the points 2, 1, 3, 4, -3, 6, we get a right triangle. How can we identify a right triangle? We know if one angle of a triangle is a right angle, then it is a right triangle. But we have given only the coordinates of the vertices. Can we find the angle using these vertices? No. We can find the distance between these points, means we can find the length of the sides. How can we identify a right triangle from its sides? We know for every right triangle, hypotenuse square is base square plus altitude square, and hypotenuse is always the largest side. Therefore, if the sum of the squares of the smaller side is equal to square of the largest side, then it is a right angle triangle. That means if hypotenuse square equal to base square plus altitude square in a triangle, then it is a right angle triangle. So let us find the sides at first. We can give a name for the vertices. Let A be 2, 1 and B be 3, 4 and C be minus 3, 6. Let us find the side AB at first. The length of the side AB is the distance between the points A and B. And we know the distance between 2 points is root of x1 minus x2 whole square plus y1 minus y2 whole square. Here x1 is 2, x2 is 3, y1 is 1, y2 is 4. So this can be written as root of 2 minus 3 whole square plus 1 minus 4 whole square. 2 minus 3 is minus 1 and 1 minus 4 is minus 3. So this can be written as root of minus 1 square plus minus 3 square. Minus 1 square is 1 and minus 3 square is 9. So this can be written as root of 1 plus 9 and that is equal to root 10. That means the length of the side AB is root 10 units. Now let us find the length of the side BC. It's the distance between the points 3, 4 and minus 3, 6. Therefore that is equal to root of 3 minus minus 3 square plus 4 minus 6 square. 3 minus minus 3 is 3 plus 3 or 6. 4 minus 6 is minus 2. So this can be written as root of 6 square plus minus 2 square. 6 square is 36 and minus 2 square is 4. So this can be written as root of 36 plus 4 and that is equal to root 40. That means the length of the side BC is root 40. Now let us find the length of the side AC. It is the distance between the points 2, 1 and minus 3, 6. So that is equal to root of 2 minus minus 3 whole square plus 1 minus 6 whole square. 2 minus minus 3 is 5 and 1 minus 6 is minus 5. So this can be written as root of 5 square plus minus 5 square. 5 square is 25 and minus 5 square is also equal to 25. So this can be written as root of 25 plus 25 and that is equal to root 50. That means the length of the side AC is root 50. Length of the side AB is root 10, BC is root 40 and AC is root 50. AB and BC are the smaller sides. So let us find the sum of the squares of them. Since AB is root 10, AB square is 10. BC is root 40, BC square is 40. And 10 plus 40 is 50, which is the square of AC. That means AB square plus BC square is equal to AC square, or base square plus altitude square is equal to hypotenuse square. Therefore, this triangle is a right angle triangle. Another problem. A circle of radius 10 is drawn with the origin as center. Check whether each of the points with coordinates 6, 9, 5, 9, 6, 8 is inside, outside or on the circle. Write the coordinates of 8 points on the circle. Here the radius of the circle is 10 units and center is at the origin. We have to determine these points are on the circle or inside the circle or outside the circle. If the distance from center to these points are equal to 10, then they are on the circle, since the distance is equal to the radius. If it is less than 10, the point is inside the circle. If it is more than 10, it is outside the circle. So let us find the distance from the center to each of these points. Here the center is the origin. Therefore, the distance between origin and 6, 9 is root of x square plus y square or root of 6 square plus 9 square. 6 square is 36 and 9 square is 81. So this can be written as root of 36 plus 81. 36 plus 81 is 117. So this is equal to root 117. We know root of 100 is 10. Therefore, root of 117 is more than 10. That means the distance from the center to this point is greater than 10. Therefore, this point is outside the circle. Now let us find the distance from the origin to the second point. The point is 5, 9. Therefore, the distance is root of 5 square plus 9 square. 5 square is 25 and 9 square is 81. So this can be written as root of 25 plus 81. 25 plus 81 is equal to 106. So this is equal to root 106. Root of 100 is 10. Therefore, root of 106 is more than 10. Since the distance from the center to this point is greater than the radius, this point is also outside the circle. Now let us take the third point. It is 6, 8. Let us find the distance from the center to this point. It's equal to root of 6 square plus 8 square. 6 square is 36 and 8 square is 64. So this can be written as root of 36 plus 64. 36 plus 64 is 100. So this is equal to root 100. And we know root 100 is 10. That means the distance from the center to this point is 10 units, which is equal to the radius. Therefore, this point 6, 8 is on the circle. Now we have to find the coordinates of 8 points on this circle. We can find 12 points on this circle easily. You can write any 8 of them. Here the center is at the origin and radius is 10. It is on the x-axis and 10 units to the right of the origin. So the coordinates of this point are 10, 0. This is also the radius of the circle. Therefore, the coordinate of this point are 0, 10. This is also the radius of the circle. So this point is minus 10, 0. And the coordinates of this point are 0, minus 10. So using the radius, we have got 4 points on the circle. Now we have already seen that the point 6, 8 is on the circle. Now let us change the sign of the x coordinate. Then we get minus 6, 8, which is also a point on this circle because the distance from the center to this point is root of minus 6 square plus 8 square, and that is equal to 10. Again, let me change the sign of the y coordinate also. So we get another point on the same circle, which is minus 6, minus 8. It's on the circle because root of minus 6 square plus minus 8 square is again 10. Now let me change the sign of the x coordinate once again. So we get another point on the circle, which is 6, minus 8. Because root of 6 square plus minus 8 square is 10 again. So we got 4 more points by changing the sign of the coordinates. Since root of 6 square plus 8 square is equal to 10, root of 8 square plus 6 square is also equal to 10. That means the point 86 is also on this circle. Simply interchanging x and y coordinates, we get another point on this circle. Now, changing the sign of the coordinates, we get 3 more points which are on the circle. That is minus 8, 6, minus 8, minus 6, and 8, minus 6. So altogether we have got 12 points which are on the circle, and we can write any 8 of them. Center is the origin and radius is 10. Therefore we get 4 points. 10, 0, minus 10, 0, 0, 10, 0, minus 10. 6, 8 is a point on the circle. Therefore, we get 4 more points. 6, 8, minus 6, 8, 6, minus 8, minus 6, minus 8. 6, 8 is a point on the circle. Therefore, 8, 6 is also a point on the circle. Again, we get 4 more points. 8, 6, minus 8, 6, 8, minus 6, minus 8, minus 6. Now, there is a homework. Find the coordinates of the points where a circle of radius root 2 centered on the point with coordinates 1, 1 cut the axis. We shall discuss the remaining part in the next video. Till then, bye.